Welcome to part 2 of body comp assessment. So with skin folds, the accuracy is compared to hydrostatic weighing is about 3.5 plus or minus 3.5%. For hydrostatic weighing, it's about 1 to 2% from actual. So although skin fold isn't exact, it's still a pretty good measurement. And the nice thing about skin folds is when you do post measurements, it's a good method to compare pre and post. Now understand, when you're doing skin folds, you're measuring the skin fold thickness, not the body fat. And then you're using skin fold thickness to determine body density. Once you have body density, you can put that in a formula based on different characteristics to determine body fat. We have different sites for males and females. For females, we measure the tricep. Notice that the fingers are on top of the fold, and you pinch with with 2 digits, and then you measure directly below that. You'll have a chance to do this in exercise physiology lab. We have the suprailiac, which is here. It's a diagonal fold. You can actually palpate the iliac crest, and it's a diagonal fold right in front of the iliac crest. And then you have the thigh, which is midway down the thigh and on the midline, so it's right in the middle. For males, we have a diagonal fold on the chest between the nipple and the shoulder, and then we have the abdomen, which is a vertical fold a couple of centimeters from the belly button or the umbilicus, and then the thigh, again, it's halfway the distance on the thigh right on the midline. When you get those, you have specific formulas for males and females. So let's look at this, because for your lab, I give you numbers, and then you use those numbers to calculate body density and then body fat. So here's an example. So you want to make sure that you refer to this whenever you're doing that lab. I have the PowerPoint for you, so you don't have to watch the video again unless you really want to. So X1 is the sum of triceps, suprailiac, and thigh skin folds. So you take the measurements and then you add them all up, and then you add them all up again here, and you square that value, and then it's times this coefficient times age in years. So for this one, we had triceps was 16 millimeters, the suprailiac was 16, and the thigh was 22, and the age of the person is 22. So when we add those sums, we get 54. So we plug in 54, plug in 54 here, take the square of that, plug in 22 here. These are the numbers that we get when we multiply 54 times this coefficient. And so the body density is 1.04963,606. You keep all of those significant digits because you're going to take that body density and you're going to plug it into a formula based on ethnicity, athleticism, the clinical population. There is a table in the ACSM guidelines for exercise testing, which is your one of your textbooks for this course, that has these equations. So let's use this one. The Jackson-Pollock 3-site skin fold for women. We determined body density. So we're going to take 4.96 divided by body density minus 4.52 times 100%. This is just a given formula. This particular formula is used for women, college-age females. It's a pretty popular one to use. So when we do that, we get 4.73 minus 4.51 times 100%, because it's a percent body fat, which is 0.22 times 100%, which gives us 22.0% body fat. There's also hydrostatic weighing. Hydrostatic weighing is based on Archimedes' principle that an object submerged in water is buoyed up by a force that's equal to the volume. So whenever you do hydrostatic weighing, you blow out all of your air, and then your underwater weight is taken and it's put into a formula to determine body density. We actually do this in exercise physiology lab, which is 340 lab. So I encourage you to volunteer to do this. It's a really cool test. Bioelectrical impedance sends a small current through your body, and then based on the time it takes to complete that circuit, it's thrown into an algorithm to determine body fat. It's important to understand that this is contraindicated for people that have arrhythmias or they have pacemakers because it could interfere with those charges. Finally, let's talk about calculating target body weight, and I'll give you an example here before we close out this chapter. So in these examples, fat mass is the FM portion, body mass, and then so fat mass equals body mass times percent body fat divided by 100%, and then fat-free mass is simply the body mass minus the fat mass. And then to get target body weight, you take the fat-free mass and divide it by 1 minus your desired percent body fat divided by 100. Let's just show you an example of that. I think it'll be a little bit easier. So in this example, a 40-year-old woman weighs 155 pounds, which is 70 kilograms, and has a percent body fat of 30. Her goal is to reach 23% body fat. What is her target weight? To start, we take the fat mass and use this formula. Fat mass equals body mass times percent body fat divided by 100%. When we plug in our values, we have fat mass equals 155 pounds times 30 divided by 100. And when we calculate this, it's 46.5 pounds of fat mass. Now, fat-free mass is simply the body mass minus this fat-free mass. So we use the 155 again and subtract 46.5, which is the fat mass, and we get 108.5 pounds. So she has 46.5 pounds of fat mass, and the fat-free mass equals 108.5. All right, so then what do we do to get target weight? Well, we simply use the formula and we plug in the values. So in this case, the fat-free mass is 108.5. Then we divide that by 1 minus the desired percent body fat divided by 100. So we have 108.5 divided by 1 minus 23 is her target body fat divided by 100. So we have 108.5 divided by 1 minus 0.23, or 108.5 divided by 0.77. When we calculate this, we get 140.9 pounds. So her current weight is 155 at 30%. To get it to 23% body fat, she needs to lose weight so that she ends up weighing 140.9 pounds. So if you have a client that they want to lose weight, you're like, well, let's figure out a percent body fat goal. You can use their current weight and the percent body fat goal to calculate target weight. There's also examples in your books. So if you have questions about this, please let me know.